This is Agent Mode AI. I'm Abby. Today we're walking AM136, 24 months of operational record across the 5 major foundation model providers: Anthropic, OpenAI, Google, AWS Bedrock, Azure OpenAI. The procurement question the record answers is whether single provider dependency is a viable architecture for production agentic AI in 2026.
I'm Avery. Frame the answer first.
The procurement defensible answer is no. Across the 24-month window, May 2024 to April 2026, every major provider experienced at least one multi-hour outage that exceeded the SLA-credit threshold defined in its published terms. Multi-provider routing with documented failover and hard dollar incident liability above the standard SLA credit cap is the mitigation. Single provider preferred vendor architecture is not the procurement defensible default in 2026.
Why the status pages do not tell procurement what they need to know.
A vendor status page reports the operational state of the gateway and the regional infrastructure surrounding the model. It does not report the operational state of the specific model the customer integrated against. A customer running production traffic through Claude 3.7 Sonnet during a Sonnet-specific degradation can be told by the status page that the API is operational, while their production agent is returning errors or degraded responses. This is not a vendor failure. The status page reports what it reports. The procurement gap is that the customer's own observability is the leading indicator. Per model latency, per model error rate, per model degradation patterns, all separately from the gateway's published metrics. The agent observability comparison at AM123, Langfuse, Arise, Helicon, Lang-Smith walks the 4-platform decision. The relevant procurement signal there is that the observability platform must capture per model signals, not just gateway signals. A customer that relies on the vendor's status page as its operational signal has no leading indicator of model-specific issues until production traffic itself reveals them.
The SLA credit gap.
The standard published SLA across major foundation model providers commits to 99.9% monthly availability, with credits capped at 25 to 50% of monthly fees on the affected service. The arithmetic on 99.9 is roughly 43 minutes of allowed monthly downtime. The arithmetic on the credit cap for an enterprise paying an indicative $50,000 per month against a single provider is a maximum of $25,000 returned in the worst month, a fraction of the operational impact a multi-hour outage produces on a customer-facing workload. Those figures are illustrative, not surveyed.
What do enterprise workloads actually need?
Customer-facing agentic deployments typically need 99.95 availability with hard dollar incident liability above the SLA credit cap, not service credits as the only remedy. The 0.05 gap is roughly 22 minutes per month of additional downtime tolerance, material on a workflow where every minute of downtime translates to a measurable customer impact. Negotiating up from 99.9 to 99.95 is contractually possible at the enterprise tier of every major provider. The negotiation requires 3 procurement instruments: a documented business impact analysis showing per-minute cost of downtime, a named incident severity tier framework with response time commitments, and an explicit hard dollar liability ceiling that exceeds the SLA credit cap. Walk the 5 providers briefly. Anthropic publishes incidents at status.anthropic.com. The operational pattern across 2024-2026 is a small number of multi-hour incidents per year, typically affecting a specific model version or region, with detailed postmortems published within 7 to 14 days. OpenAI publishes at status.openai.com. The operational pattern includes the broader incident class of credential/quota system failures that affect the entire API surface, alongside model-specific incidents. Credential system incidents are particularly procurement relevant because they cannot be mitigated by switching models within the same provider.
Google.
Google Gemini API publishes at status.cloud.google.com within the broader Google Cloud Platform status surface. The operational pattern inherits the GCP regional fault domain structure, plus Gemini-specific incidents are reported, but require the customer to filter the broader status feed.
The hyperscalers.
AWS Bedrock publishes at the AWS Service Health Dashboard. Operational pattern inherits AWS regional infrastructure, plus Bedrock-specific model availability across regions. Bedrock customers benefit from cross-region inference patterns that mitigate single-region failures within the provider, but do not mitigate Bedrock-wide incidents. Azure OpenAI publishes at the Azure Status Dashboard. Operational pattern inherits Azure regional infrastructure plus the Azure OpenAI integration layer. Azure OpenAI customers can deploy across multiple Azure regions for failover. That pattern mitigates regional incidents, but does not mitigate the OpenAI side issues that propagate through the Azure integration.
The procurement-relevant read across all 5.
No provider is a clean choice for single-provider production deployment in 2026. The architecture has to assume failure across the provider graph regardless of which provider is chosen. The relative ranking depends on which workload class the customer cares about. Hyperscaler-backed offerings inherit the underlying cloud's regional fault domains, plus model-specific failure modes. Frontier Lab APIs have a shorter operational history, but more direct upgrade path optionality on model versions. Both classes have material incidents in the 24-month window.
3 architectural patterns for multi-provider routing.
Pattern 1. Gateway abstraction. A gateway sits between the application and the foundation model providers and routes traffic based on configurable rules. Light LLM is the open-source reference implementation. Open Router and Portkey are commercial alternatives. The gateway provides a unified API surface that the application integrates against with the underlying provider selection happening at routing time. Failover is observable, configurable per route, and testable in production. The procurement defensible benefit is that the customer owns the routing logic and is not dependent on the vendor for failover capability.
The cost of Pattern 1.
The gateway becomes part of the customer's operational substrate, its own observability requirements, its own latency overhead, typically 50 to 150 milliseconds added per request, and its own change management discipline. Enterprises running this pattern typically deploy the gateway in their own VPC with redundancy across availability zones, treating it as production-critical infrastructure equivalent to an API gateway or service mesh.
Pattern 2.
Provider-side regional failover. Within a single vendor, the customer deploys across multiple regions and handles failover at the regional level. AWS Bedrock cross-region inference and Azure OpenAI multi-region deployment are the 2 production-grade implementations. Partial mitigation, it addresses regional failures within the vendor's fault domain, but does not address vendor-wide incidents. A Bedrock-wide outage affects all regional deployments simultaneously, appropriate for workloads where vendor-wide incidents are tolerable, but regional incidents are not.
Pattern 3.
Explicit multi-provider provisioning at the application layer. The application is built to support 2 or more model families with prompt-tested compatibility maintained as a deployment requirement. The customer maintains active provisioning with a primary and secondary provider. Failover is application-driven, most expensive to maintain because every prompt change requires testing across the supported providers. Most resilient because no shared failure mode with the gateway or any single vendor's regional architecture. Appropriate for high-availability customer-facing workloads where the per-incident cost exceeds the maintenance overhead of multi-provider support.
The default for 2026 enterprise procurement.
Pattern 1, gateway abstraction, is the default for most enterprise workloads in 2026. Pattern 3 is the higher rigor option for the workloads that justify it. Pattern 2 is a partial mitigation appropriate for narrower workload classes than most enterprises initially assume.
3 contract language additions for the 2026 AI MSA Red Team checklist.
First, hard dollar incident liability above the SLA credit cap. Named incident severity tiers, typically SEV 1 customer impacting, SEV 2 degraded service, SEV 3 minor impact, SEV 4 informational, with per tier response time commitments and an explicit hard dollar liability ceiling that exceeds the SLA credit cap by a multiplier reflecting the customer's per minute downtime cost. Achievable at the enterprise tier of every major provider.
Second,
Non-degradation clauses covering model deprecation events. The vendor's right to deprecate or update models is the customer's procurement risk. The 2026 standard is a contractually defined transition window, typically 90 days for major version changes, 30 days for minor, during which the customer's prior model version remains available alongside the new one. The clause is required because forced cutover with no transition window produces a regression test sprint the customer's engineering organization cannot consistently absorb on the vendor's schedule.
third,
Right to multi-provider routing without contract penalty. Some 2024 vintage MSAs included vendor exclusivity clauses that prohibited the customer from routing identical traffic through a competitor's model. Those clauses do not survive 2026 procurement diligence because they make Pattern 1 and Pattern 3 contractually infeasible. The procurement defensible language explicitly preserves the customer's right to deploy multi-provider architectures and prohibits the vendor from using identical traffic routing as a basis for contract enforcement action.
What does the AM136 verdict look like?
AM136 is holding on a 30-day cadence. The reliability record is the kind of evidence that ages monthly, not quarterly. The procurement defensible posture has to refresh against the most recent operational data the providers publish. 3 triggers would shift the analysis. A foundation model provider publishing a sustained 99.99 operational record across 12 consecutive months would close the gap between the standard 99.9 and the enterprise-required 99.95. A regulatory development requiring multi-provider provisioning for high-risk AI deployments under the EU AI Act would shift the procurement question from architectural choice to compliance requirement. A landmark vendor outage producing material customer harm and follow-on litigation would shift the SLA credit versus hard dollar liability negotiation.
The honest read on what to do Monday.
3 actions. First, audit the current foundation model architecture against the 3 patterns. If the deployment is single provider with no routing layer, prioritize Pattern 1 in the next quarterly engineering plan. Second, audit the current vendor MSA against the 3 contract additions. The renewal window before August 2, 2026 is the natural moment to negotiate them. Third, instrument the customer's own observability stack against per-model signals, not just gateway signals. The lead time on model-specific degradation is the difference between a bounded incident and a customer impact incident.
Final word.
Me, Blay J. Holding up. See you next Sunday.